Hello and welcome to today's class. Let's look at the fifth example under first principle method of differentiation, and then we'll look at yet the third method of differentiation called the chain rule method of differentiation in our next video, or perhaps in the next class. Let's say I have that y is equal to 1 over x squared. I'm going to solve this man here using what's it called, first principle. What do? You can try your best to find out the value that you have using general method, as I used to do before now. But to save time, let's just get into the job there and get it done. What we know that is that so y had change in y is equal to 1 over 2x add what change in x. But mind you, I have a square. I have it here. What's the next task from here? It's quite easy task. Take this y to the other side. I'll have that change in y is equal to 1 all over what there, x plus change in x all squared minus y. Why is this minus y? Is because I have a plus y here, and if a plus y crosses the equality sign to the other side, becomes a negative y. Proceeding from here, at this junction, but from the question, what's y? Y is what? 1 over what? X squared from the question. So it means anywhere I see y, I'll put 1 over x squared there. It's as easy as that. From here, I'll have that change in y is now equal to 1 over x plus change in x all squared minus y. What's now y? Y is 1 over x squared. All right. So I have this one here as my expression. We said in our previous class before now, when we did 1 over x alone, we said at this junction where you have two fractions this way, and you have either positive sign or negative sign in the center, what comes to mind? LCM. So let's get the LCM, and we said that if I have two uncommon terms, the LCM then becomes the 2, right? So the 2 here becomes the LCM. So I'll have that change in y is equal to 1 all over x plus change in x all squared, this man. Okay, to save time, okay, right, the LCM is the 2, right? So perhaps I can make okay, I wanted to repeat the question here, but to that we make our work very slow. What do I just do? The LCM is this, so Abby just put the LCM there, x squared into x plus change in x squared. These are my two LCM value. Let's have this first one. If this first one cancel that same thing here, I'll have only this one left. This man that is left times 1 is that man, that's x squared. This is a minus sign, a minus. If this one cancel this same thing here, I'll have just only this left. Now only this value times 1 will give you x plus change in x all squared. So I have this expression in front of us. All right, from here, what's the next procedure to do? My next task from here is quite easy and easy, right? So I'll take this y, change in y is equal to, I'll try to expand this. This becomes x squared minus, if I expand this, open a bracket, if I expand x plus x squared, I shall have x squared plus 2x change in x plus change in x squared. I will not take my time now to expand this for you now. I have done that in like inside 3 videos, how to expand that value. So if you have been following us from our initial classes, right, you should know how to expand this at this level, at this point. All right, I have now all over, denominator comes down, that's x squared into x plus change in x. And also observe, After expanding, I still keep the term inside the bracket. I didn't remove the bracket. It must be in the bracket. All right, I'll have that change in y is now equal to x squared minus times x squared is minus x squared. I'll use minus to expand the bracket. True. So minus times x squared is minus x squared. Minus times plus 2x change in x. That's minus 2x change in x. Minus plus is minus. Come having left change in x squared all over. I asked you before now that you can try this question using general method and keep your answer pending somewhere, and then whatever I have with me here, you can compare them together. If it's wrong, let me know in the description in this comment section, and if it's correct, let me know. So I'm saying that try this one alone using general method. I think that is the fastest way. So keep your answer somewhere, and I didn't solve for general method, so let me just solve this finish, and whatever I have as my answer, compare it with what you're having in your own general method when you use this one, and tell me if I'm correct or wrong in the comment section below. I'll repeat down my denominator. I'll have x squared into x plus change in x, right? From here, this will cancel this, so I'll have change in y to be equal to what is left, minus 2x change in x minus change in x squared all over x squared into x plus change in x as the left value there. From here, my next procedure is quite easy. So after cancelling out, what's the next thing that comes to mind? I'll divide true by change in x. So shall I have? I'll have change in y over change. So divide true by change in x. I shall have this change in y by change in x is equal to, I'll repeat everything down here. I'm going to try to manage the space. Minus 2x change in x minus change in x squared all over x squared into x plus change in x. So I have this one, repeat it down, then divide it by what? Change in x. It's more similar to the fourth example we did in our previous class, right? That one was having 1 over x alone. The same concept applied with it, but just that in this case you have to expand this one this way. For the last one we did, when it was just having x, we didn't expand, right? From here now, I will still have my normal change in y in x. Change in y over change in x is equal to, repeat everything here, minus 2x change in x minus change in x squared all over, this one here becomes x squared into x plus change in x, right? This division becomes times, there's an invisible one here over 1, so this one comes up first over change in x. But observe in this case, this can't cancel anything here, but I can make it an expression that can cancel. In what way? This becomes change in y over change in x is equal to, observe that change in x is common from the two, bring out 1 in x into minus 2x minus change in x, right? All over what? Observe that this times this I'll have this, this times this I'll have this, so it's like factorizing. That's the concept. So this times 1 over change in x. Repeat this, x squared into x plus change in x. What next here? This man cancel this. What am I having left? This times this itself. I have minus 2x minus change in x all over what there? X squared into x plus change in x. So this one becomes change in y in x equal to this. We said after dividing through by change in x, and you are still left with what in x, Take it as what? At 0. So I'll take change in x as what? At 0. To save time, to save space, this becomes change in y over change in x is equal to minus 2x. If I put 0 here, it's off already. So I have minus 2x left. All over, if I put 0 here, I just have s alone. So I have x squared, right, into this x alone. This is 0 already, it's off. So this will give me minus 2x all over x squared times x, that's x cubed. I can leave my answer this way, but yet I'm not yet correct. Observe that s can cancel out s cubed. I'll have x squared left at the denominator, right? So I'll have x squared left here. So it means that my final answer, let me just put my final answer here. My final answer becomes change in y over change in x is equal to what? Minus 2 over x squared. This becomes my final answer after solving this particular problem. This is how you evaluate problems using the first principle method of differentiation. In the next class, we'll look at the third method called the chain rule method of differentiation. See you in the next class. If you found this class helpful, do it to like, hit the subscription button, subscribe to my channel, share to your friends and classmates that can learn too. If you're also a student from maybe American, UK, or anywhere in the world, and you want me to help you do your assignment, I have a website where I help students do the assignment. Register with us, perhaps, or you send me a WhatsApp number. You see my WhatsApp number in the description of this video. So do well to check there and send me a message. Then I can be of help to you. I also take personal tutorials online. If you're interested, just reach me out. So see you in the next class. Thanks for watching and welcome to Excellent Link Academy. Hold on guys a little bit. Let me tell you what you need to know. Actually, I'm running a membership program, right, which can help you a lot. So to join my channel membership, it's quite easy task, right? As you can see the icon I'm showing you here, that icon is my membership opportunities, which you can access monthly. So I'll drop the link to the membership in the description of this video, right? So just click there, click on the membership link, so you purchase the one you want. So I have for JAM and YA classes, and also I have for 100 level students. So whichever one suits you, click there and subscribe. Perhaps click there and purchase the one of your choice. Anyone you purchase, there are several advantage videos that I will not allow people to see. So it's for only those who have joined the channel that will have access to those even advanced problems. And also I do help students from different countries to solve their assignments. So if you're in UK or abroad or Canada or anywhere you are in the world and you want me to help you do your assignments, you can simply you can simply visit me on my WhatsApp number, or also share this video. I'll drop a link to a website there. In the website, you can register with us and you let us know which assignment you want us to help you to do. Do well to join the channel. Thank you. You can proceed with your learning now.